Good afternoon. Once again, my name still remains HND2 Joshua Aldendu. I'm here to walk you through Start 2 and to prepare you for your forthcoming examination. So, in this course, we'll be looking at some set of questions that are likely to come out for you to focus on, and also for you to practice with. This is just a guideline, so please, as we go through, I pray that God give you understanding for you to understand more. Now we have question 1. 1A says differentiate between the likelihood function of the random variable x1 with the PDF of the function x1 theta and maximum likelihood estimator of a population with parameter theta. Now, the solution to that problem is very simple. Let's go. The likelihood function of random variable x1 to xn is the joint density function of the random variables, which is considered to be a function of the parameter of the distribution. Now, in this case, if we have x1 to xn to be a random variable with density function x1 theta, then the likelihood function L will be x1 theta, which is equals to f, that is the function x1 theta, to fxn theta. And using this code, we have what? The product of fx1 theta. That the symbol there signifies we have what? Array product. Why the maximum likelihood estimate of the parameter theta with PDF function x1 theta is the value of theta that maximizes the likelihood function. So the maximum likelihood estimator is the one that is what? Maximizing the likelihood function. Firstly, to get the maximum likelihood estimator, what this place is telling us about that you have to get the likelihood function L. So it is this likelihood function L that you can use to proceed to get the maximum likelihood function. So in the maximum likelihood function, we have a partial differentiation over a partial differentiation theta into bracket log L, where theta is the maximum likelihood function. Now, what are the properties? The properties of maximum likelihood estimator are as follows. 1, maximum likelihood estimator is not necessarily unbiased. When you say it's unbiased, it means that what? At the end of the day, you are not getting anything that is less than 1. Rather, a maximum likelihood, it can be biased, it can be what? Unbiased. So if you have a solution that is unbiased and they ask you to look for maximum likelihood estimator, don't say you are what? You are wrong, because one of the properties of MLE is that what? It is not necessarily what? Unbiased. It can be biased, it can be what? Unbiased. It is biased when lambda is equal to 1, it is unbiased when lambda does not equal to what? 1. Now, MLE is consistent, which is the basic function of MLE, is consistent, most efficient, and also sufficient. Consistent means that the likelihood solution continue from the first solution to the end. That is consistent. It does not what? Change easily. Is efficient in the sense that what? MLE is very, very what? Important for those people doing what? Estimator. The statisticians, they use what? MLE because what? Is consistent, is efficient, and is also what? Sufficient when carrying out what? Estimator. MLE tends to, the third one, MLE tends to be distributed normally for large what? Sample. Now, if G theta is a function of theta and theta bar is an MLE of theta, then G into bracket theta is the MLE of G into bracket theta bar. Now, 1B, we are asked to identify and find the maximum likelihood estimator of theta for a distribution whose density function is f into bracket x comma theta close the bracket equals to theta exponential raised power minus theta x. Now, firstly, you differentiate it. You can see there from the diagram that from the picture that we have theta e raised to power what minus theta x. Now, the theta is being what is being separated, introducing the word multiplication sign, which is dot. Now we have theta raised to power n. N there stands for what? A continuous number. We don't know where our n is. If n is 1, then we are going to stop at e1. If n is 2, we are going to stop at what? Theta e2. Now that's why we have theta into bracket theta raised to power n dot stands for what? Multiplication into bracket e1 raised to power minus theta dot e2 raised to power minus theta x, and so on till you have what? En raised to power minus what? Theta x. Now in this case, since our theta is raised to power what? N, that's why we have what? E base n raised to power what? Minus theta x. Now we continue introducing the word the stigma, which stands for multiplication. Since we have e1 to en, we introduce that stigma to show that what e is continuous to what? To en. Now we have theta raised to power n dot stigma e raised to power minus s. Now we introduce the what? The likelihood function. The likelihood function L s into bracket theta is equals to theta raised to power n dot stigma e raised to power minus theta x. Okay. Now we have log theta n, introduce that dot, change that dot to multiplication sign, times log stigma e raised to power minus theta x. Then now we have gotten our likelihood function. Like I said earlier on, after you get your likelihood function, it is your likelihood function that you now use to get your MLE, which is what? Maximum likelihood what? Estimator. Before you proceed in finding what? MLE, maximum likelihood estimator, you must first look for the what? The likelihood function of that of that PDF, or the distribution function.
So you're not charging again.
We are deeply sorry for the break in transmission. So we are looking for the likelihood function. Like I said earlier on, the likelihood function L x into bracket theta we have equals to theta raised to power n dot stigma e raised to power minus theta x. Now introduce your log. You have log theta raised to power n times log stigma e raised to power minus theta x. Now let's look for the maximum likelihood function. We have the partial differentiation L over the partial differentiation theta equals to n log theta. Recall in your law of logarithm, if you have theta raised to power what? N, log theta raised to power n rather, n can come over, then you have what? N log theta plus n log theta plus, then you do the same thing for the other part, minus theta x log stigma e. Now you have n log theta to be equal to n log theta minus theta what? X log by e. Then we have n over theta minus x log by. Now recall that e raised to power e is equals to what? 1. So x will now be x times what? 1, which is x. So we have n over theta minus what? X. Equate our equation to be 0. That is, from log L, which is your likelihood function, to your MLE, we have log L A into bracket x comma theta over partial differentiation theta equals to n over theta minus x equals to 0. Now clear fraction by multiplying through by what? Theta. So by the time you multiply through by